565. Uh-oh. All right, it says in example 2, you found that the tangent of 30 degrees is about 0.58. So it follows that if the tangent of an acute angle is about 0.58, then the angle measure is 30. All right? So it always works that way. Okay? So in other words, this gives us a method to figure out what angle measures are. All right? If the tangent of 30 is always 0.58, 30 degrees is the only angle whose tangent is 0.58. There are no other angles whose tangent equals 0.58. So that means if we know the tangent is 0.58, we can just use logic to say, well, that means the angle must be 30 degrees. Now, there's a lot of rounding when we're doing this, okay? So pretty much everything we're doing with this is an approximation. Well, that's the best we can do, so that's what we got. So here are the definitions of the inverse trig ratios. All right, it says if angle A is an acute angle and the sine of angle A is x, then the inverse sine of x, inverse sine of x, is the measure of angle A. It seems like a bunch of gibberish, doesn't it? All right, here's what you need to get from this. Here's the notation you use for inverse sine. It looks like sine to the -1. It's not an exponent. It's called a superscript of -1. That means inverse sine. So inverse sine is what we use when we're trying to find an angle measure. Now, I could go through all 3 of these definitions, but I'm not too sure they'll make very much sense to you. So instead, let's look at this. Since the sine of 30 degrees equals 1/2, okay, let's pretend that you don't believe me. We do this, make sure we're in degree, and we do the sine of 30, 1/2. Then the inverse sine of 1/2 equals 30. Let's say you don't believe me. Now notice on your sign button on most calculators, above the sign button in yellow on mine, it has sine with a -1 on it, inverse sine. So if I hit the second button and then the sine button, I get inverse sine. So if I do the inverse sine of 1/2, it had better give me 30. So see if your calculator has the ability to do inverse sine, inverse cosine, inverse tangent. Let's see if you can make that work. On your calculator, try doing the inverse sine of 1/2 or the inverse sine of 0.5 and get 30. If you don't get 30, then you're not in degree. A problem that has come up in the past is that once you've learned how to do inverse sine, you want to do inverse for everything. Nope. The only time you do inverse is when you're trying to find an angle measure. The only time you use the inverse of sine, cosine, or tangent is when you're trying to find an angle measure. All right. Sorry, didn't mean to scare you. Oh, hang on. All right. Let's take a look at 4A from page 565 from the Check Your Progress. Like yesterday and the day before, we needed to work a few that weren't from your assignment to get enough examples for you to get good at it. So same thing here. Down. They're not actually part of the assignment you're going to get here in a minute, but there are examples you need to have. The directions say, use a calculator to find the measure of angle A to the nearest tenth. All right. So on 4A, here's angle A. Now, I'm going to make this in 2 steps. Look, you can do this in 1 step. I don't want you to. In fact, what we were doing in calculus today has to do with what I'm getting ready to show you. So what I'm getting ready to show you has value beyond just trying to get the answer for now, okay? I'm going to write this out. According to this triangle, the sine of A equals opposite. Wait a minute. I don't want to use sine because I don't know the hypotenuse. What should I use? I still don't know. Tangent. I need to use tangent. The tangent of A equals opposite over adjacent. All right, so we've got an equation. Now, yesterday, they had us do problems where that's all we had to do, right? But now, there's actually an unknown in that. I don't know what angle A is. So I'm going to treat that as an unknown. So if the tangent of A equals 6 over 20, that means that the inverse tangent of 6 over 20 equals the measure of angle A. I didn't do any algebra. I didn't do something to both sides of an equation. That's not what I did. I used the definition, which you don't have to memorize the definition. You have to know it works this way, though. Since the tangent of A equals 6 over 20, the inverse tangent of 6 over 20 equals A. Okay? So now I use my calculator. So I want you to put those two steps before you go to your calculator. And now in our calculator, what do I need to type in? I need to type in the inverse tangent of 6 over 20. So, hit my second button and then tangent. That gives me inverse tangent on the screen. 6 divided by 20. All right, to the nearest tenth, 16.7 is the measure of angle A. You with me? Now let's do 4B. All right, again, I want A. What should I use this time? Sine, cosine, or tangent? Cosine? I can write the cosine of A equals adjacent over hypotenuse. If the cosine of A equals 3/15, then the inverse cosine of 3/15 equals A. And now I use my calculator. Inverse cosine, 3 divided by 15. So 78.5 to the nearest tenth is what the measure of angle A equals. Somebody say that's easy? Good. All right. Now, to solve a right triangle, which has been our goal, to solve a right triangle means to come up with the length of every side and the measure of every angle. Okay? We can use Pythagorean theorem. We can use trigonometry. If we have a 45-45-90, we can use that information. If we have a 30-60-90, we can use that information. Okay? So, if we take a look at this one, 5A, it says solve each right triangle. All right. Well, look what's missing. I need to find that side, and I need to find that angle and that angle. It doesn't really matter what order I go in. Okay? So, what do you want to do first? Do you want to tackle the angles, or do you want to figure out the missing side? Angles? All right. You want to find F first or G first? F? All right. So, let's get F. Now, if I'm going to find F, should I start off taking the sine of F, the cosine of F, or the tangent of F? Be careful. That's the hypotenuse, isn't it? All right, so the sine of F equals opposite over hypotenuse. You gotta choose the one that you have the information for. Okay? All right, so if I've got that, that means the inverse sine of 5/13 equals F. And now let's use our calculator. The inverse sine of 5/13. So that'll be about 22.6 for the measure of angle F. All right. Now, I can do trig again to get G, or think about this. Remember how we talked about the acute angles and the right triangle are complementary? So can't I just subtract 22.6 from 90 and get angle G? So the measure of angle G is, actually it's approximately 90 minus 22.6. 90 minus 22.6. So the measure of angle G is approximately 67.4. So I found angle F, found angle G. Okay? Now, to find the missing side, X, the length of FH, we've got options. Now that we know angle measures, I could use trig, but remember how, if we can, we'd rather use given information, because given information has not been rounded, and given information is correct. So let's just use the Pythagorean theorem, because it'll work. We've got two sides. We can find the third, so it'll work. And in fact, isn't that one a Pythagorean triple? Anybody remember what that one is? That's okay. I wouldn't remember it either if I were you. So let's do that. Let's do. Now we know the hypotenuse this time. It's 13. All right. So one leg squared plus the other leg squared equals the hypotenuse squared. So x squared plus 25 equals 169. So x squared equals 144. So x equals the square root of 144, which is a perfectly good answer, except, yeah, that's 12. Okay? So whenever you can, use given information. So the length of F8, and we've now completely solved this right triangle. Now, how do I know we've solved it? Because we now know the length of all three sides, and we know the measure of all three angles. So we've solved it. There's nothing left as an unknown. Now, every time you solve a triangle, it might be slightly different. We could have found the length of FH first instead of last. Okay? We could have used trig both times to get angle F and angle G, but subtracting from 90 here. Okay? So there's more than one way to do each of these, and every one's a little different. If you didn't know the hypotenuse, or if you knew one of the angles already, then all you got to do is subtract to get the other one. So they're all a little bit different. Okay? But that's how you go about it. Make sense? All right, let's do another one, 5B. All right, we're supposed to solve the triangle again. Well, look, it starts off easy. I know what angle C equals. Do you? What's the measure of angle C equal? Okay, because it's 90 minus 62. So, angles are done. Now we need to get sides. All right? So, how about if I call that side X and that side Y? Using the 62 degrees, just because it's given, I know it's right. So using that, to get X, I could say that the cosine of 62 degrees equals adjacent over hypotenuse. And then we worked equations like this yesterday, didn't we? So we multiply both sides by 10, clear fractions, x. So now I use my calculator. So 10 times the cosine of 62. And so 4 point, what did they say? Here's 10, 4.7 is x. So it's 4.7. All right, I got one more thing to find. Find y, that's the length of BC. All right, again, I'm going to stick with the given information to find things if I can. And I can. From the 62 degrees again, I can use sine this time. I can do the sine of 62 equals opposite leg y over hypotenuse, 10. So then I get 10 times the sine of 62 equals y. So that's about 8.8 for y. So 8.8 is the length of BC. Scary. You with me? Questions? See what you can do with that one by yourself. Until you can share one with somebody, yeah. All right. Page 567. This is part of your assignment. All right. David is building a bike ramp. He wants the angle that the ramp makes with the ground to be 20 degrees. If the board he wants to use for his ramp is 3.5 feet long, about how tall will the ramp need to be at the highest point? So what we want to find then is we want to find that length right there, don't we? You following me? All right. Well, we can do that. All right, so let's do this. We can say, should I use sine, cosine, or tangent? Sine. We can say that the sine of 20 equals opposite over hypotenuse. Oh, this is just like we were doing yesterday, isn't it? So multiply both sides by the denominator. And let's see what our calculator has to say about it. 3.5 times the sine of 20. So about 1.2 is the height. So what's that in? Feet? About 1.2 feet is the height of the... Got it? All right. Let's try number 12. It says use a calculator to find the measure of angle Z to the nearest 10. All right, so we need angle Z. First, let's write an equation using one of our trig ratios. We know the opposite leg and we know the hypotenuse. So should I use sine, cosine, or tangent? All right, so the sine of Z equals opposite 5 over hypotenuse, 9. Now, since the sine of Z equals 5/9, that means the inverse sine of 5/9 equals Z. Well, let's see what the inverse sine of 5/9 is. So, second, and then sine gives me inverse sine, 5 divided by 9. So that'll be, what did they say to round it to? Here's 10. That'd be about 33.7 for the measure of angle Z. We okay with 12? Yes? Questions? All right. Do 13. Anybody got a problem with what I've done? Yeah, I did the wrong angle. Darn it. All right, so the cosine of Z equals adjacent over hypotenuse. This ought to work out better, shouldn't it? Is that what you got? All right, now, notice something about these two. Since I did the wrong one first, let's notice something about those two. What's the relationship between 45.6 and 44.4? Yep. They're the measures of complementary angles, aren't they? Because they add up to 90. Is that what's supposed to happen with the acute angles in a right triangle? Yeah, it is. That's exactly what's supposed to happen. Okay. All right, real quick, do 14. All right, I think I got it right this time. Did you get what I got? Okay. Now, I know that some of you live and die with your calculators. You do all kinds of arithmetic on it that I wouldn't do on it. It makes me a little nervous to be so reliant on the calculator because, you know, I don't really know what the inverse sine of 15/25 ought to look like. So I'm going to have a really hard time if I've punched something in wrong or I've set it up wrong. I have a hard time realizing I've done it wrong. Okay? So, you know, we just kind of got to get over that. We're having to make sure we do our technology the right way. Because if we don't, we're going to miss it and we're probably not even going to know it. All right, this last one. Solve the right triangle, round side measures to the nearest tenth, and angle measures to the nearest degree. All right, let's find the measure of angle R first, just because I decided to. So let's get the measure of angle R. All right, if I'm going to do that, I'm going to do what I just got through doing. Am I going to use sine, cosine, or tangent? Sine again. So the sine of R equals opposite over hypotenuse. That means the inverse sine of 6/9 will be the measure of angle R. Inverse sine, 6 divided by 9. And I get 41.8. Now they said to round it to the nearest degree. So if I round that to the nearest degree, I'll get 42. I'll take 41.8. If you get a more precise answer than what the directions say, I'll never count that wrong. Okay? So if that one's 42, what's the measure of angle T to the nearest degree? 48. All right, so I've got the two angles. So far, so good. All right, now, to get the missing side, I could use trig, but if I use trig, I'm going to be using an approximated answer for an angle that I came up with, which is okay. If I have to do it, I have to do it. But I can actually find that missing side by using just given information if I use the Pythagorean theorem. So that's what I'm going to do. I'm going to call that x. Then I'm going to say that one leg squared plus the other leg squared equals the hypotenuse squared. That would be x squared plus 36 equals 81. What's 81 minus 36? So x squared equals 45, which means x is the square root of 45. So the length of RS is the square root of 45. Now they did say round side measures to the nearest tenth, so we actually need to punch that one in this time, don't we? And again, if you leave it as square root of 45 and give me a more precise answer than the book says, I'm fine with that. But they did say to type it in, so I will. Square root of 45 be 6.7 to the nearest tenth. All right, you with me? There's your assignment. Page 567, 11 through 15, 34 through 47, 51 through 59, 62, 63, 80.